Okay, we're going to work on some algebraic expressions. Now this is what you did in class, a bit of what we've already done in class, but I just want to go over a few things. For instance, if we have 5 times w, we could write 5 times w, 5 with this expression for the x. We can write 5 and then w in parentheses. That would also be 5 times w. We could just do 5 with the w here. All of these mean the same thing. These all mean 5 times w. Each one of these. This is our standard multiplication symbol, the x. But remember, I told you we really don't want to use this x much because now when we talk about variables, most often we use an x as the variable. X equals something or other. It's the unknown variable. Now again, if you recall, I said a variable can be any letter. And many times we use a letter that's pertaining to what we're speaking of. If I was talking about marbles, how many marbles, I might use the letter M for a number of marbles because M and marbles. So all of these expressions here simply mean 5 times w. What if we had let me see, what if we had 1/2 x? What does that mean? Well, 1/2 x means 1/2. Let me do this here so we can do it in blue. We see the difference. 1/2 times x. We could do 1/2 x in parentheses. These all mean the same thing. They simply mean 1/2 times x. Remember, if you see this, you have that imaginary multiplication symbol here. Alright, what if we were talking about division? Remember what I told you. Sometimes with division problems, they look like a fraction. If I had x divided by 3, I could do x divided by 3, so 3 is my divisor. Remember, divisor, denominator. That goes on the bottom. That means the same thing. Or we could have 1/3 and put the x to the side. Because we know also that x has that invisible 1 in front of it. We don't put the 1 here because it doesn't change the number. But we know we have that invisible 1 in front of our variable. So how do I change this and put my x over here? I put the invisible, I take that invisible 1 and put it there and move my x here, which gave us this right here. Alright, it doesn't change the meaning at all. It still means the same thing. If I were to say, for instance, x equals 2, here I would put 1/2, or 1/3, I'm sorry, times 2. That's x equaling 2. Right here, x over 3, if I change the x into a 2, I could say 2/3. Would that be the same as this? Let's see. Make the whole number, put a 1 underneath it to make it a fraction. At this point, I have 1/3 times 2/1. Multiply across. 1 times 2 is 2. 3 times 1, 3. Is that the same thing? Here we go. Look at that. It is the same thing. That is algebraic magic. So this means the same thing as this, which means the same thing as this. We proved it by substituting x for 2. To see if you have equivalent equations, always substitute x for a number. You should end up with the same solution for each one as we did here. When we substituted x equals 2 or 2 for the x, plugged in the 2 wherever we saw the x, we ended up with the same thing. And that's your goal. If you don't end up with the same solution, your rewrite or your format of the original equation is incorrect. Alright, we also had things yesterday on our problems. Let's, for instance, say we had a verbal. Add b, which is the variable, to 9. That's our language, our English language. Remember what we have to do, it's like a different language. You have the English language and you have the mathematical or algebraic language. So we need to translate. Translate the English language into our algebraic language. So it says add b. So add means, oh, I know I'm going to have an addition symbol there. Add b to 9. Well, it says to 9, I'm adding the b. So I have the 9 here. Here's my addition problem. So I have add b to 9. 9 plus b. There's my algebraic expression. So I translated English into algebraic language. And there you go.